do one more thing real quick here. Okay, hopefully you guys can see what I have on my end.
Yep.
Good.
Okay, so thank you everyone for attending this week's virtual Ken Reeves Memorial Weather Briefing. Our speaker this week is Dr. Bowley, who's a professor in the department. So thank you so much, Dr. Bowley, for volunteering to do our briefing this week. And I'll just let you go ahead and get started.
Sounds good. Thanks, Alex. And thanks, Chris, to both of you for getting us all set up, as well as for the Campus Weather Service for really thriving in front of quite the headwind with everything going on this semester, as well as this past spring. So luck be it for me, I picked out a several weeks in advance that happens to have tied or set the record for the most active tropical cyclones in the Atlantic Basin, to my knowledge, in recent history at the very least. It was as advertised, a pretty active season across the board. The animation I have here is going through a little bit choppy, might be even more choppy on your end, but more or less just kind of taking a quick look at the geostationary satellites. For those of you who don't know me, I think I know almost everyone in the room, but I've been a teaching professor in the department for the past few years, and a lot of my teaching kind of focuses in on a bit on forecasting, as well as a bit on kind of a variety of topics, ranging from our 440W class to our radar meteorology class, to what kind of the bread and butter of my research is, which is in synoptic meteorology. But I think, as we all know at this point in time, no matter what you study in meteorology, two things will always happen in your career. One, no matter what you study, everything else will involve itself in one way, shape, form, or another. And two, no matter what you do in your career, be it continuing in meteorology, in a research front, in a teaching front, in a forecasting front, be it in any front, or even if you don't continue on in meteorology, inevitably your family will ask you, hey, what's going on with the weather this day, or your friends. So today I'm going to kind of take you through what's going on in the tropics specifically. And for me, I have a personal kind of item of note within this, because I have a cousin who, she and her husband are moving today. He's in the Air Force, so he was out training out in Vance Air Force Base in northern Oklahoma. So they moved out there 2 years ago, and they arrived, I don't know, somewhere between 2 and 4 weeks before the high risk day back in 2018, I think it was, out in Oklahoma. So that was their welcome. There are 2 California kids, and their welcome to Oklahoma was one of the most highly amplified forecast days in recent memory for Oklahoma. Of course, that day, luckily for them, was a bit of a bust. And then their welcoming party for them is that they're currently driving down to Elgin Air Force Base, which is a little bit east of Pensacola right now. And we, for the past 2.5 days, have been trying to figure out, A, can they drive there? B, when should they drive there? And C, how awful is it going to be if they do decide to drive there? So it seems like everywhere they move, they seem to have some sort of gnarly impact from some sort of severe mesoscale convection. This event not withheld. So we'll see where they move next and what's going to happen on that front. But I'll kind of take you guys through more or less what's been going on across the tropical Atlantic, and then at the very tail end, we'll bring it back a little bit to home here in State College. So as billed, active. So we have the remnants of Rene right now, slowly but surely working its way through the North Atlantic. Paulette made landfall or came very close to hitting Bermuda last night. I didn't actually double check on the radar data to see if they actually had a direct impact, but hurricane conditions on Bermuda impacting them, with Paula working its way through here. Sally has been the big question at hand, and kind of one of those scary storms in that I always get scared when you have storms that aren't that strong, but can have really significant impacts. And we'll kind of talk about what I mean by that as we work our way through within this. But, you know, tropical cyclones and hurricanes can be a dime a dozen sometimes in the Gulf. And ones that drop 20 to 40 inches of rain aren't so much a dime a dozen. So we're going to talk a little bit about what's going on within that. Teddy down here, this is the most recent one to form. So for those of you keeping track in our alphabet, we're starting to run out of letters pretty darn fast. Looks an awful lot like 2005 from that standpoint. Teddy right now is progged to slip north of the outer Antilles there, intensify into a major hurricane and basically bug the sharks and the fishes and the whales out in the ocean without too much major impacts thus far within that. remnants or depression 21 here, sitting off the African coastline. We have a second wave working its way off the African coastline that is expected in the 5-day range to propagate its way out into the central Atlantic with a 40% chance of development. And just because, we don't have enough going on, there is also a cluster of thunderstorms right now over the western Gulf going into the Bay of Campeche, and that is right now not too likely to form. But the Hurricane Center folks are more than earning their dollars. They're an excellent forecasting group on their own, and they're more than earning their dollars right now with what's ongoing within this event. So first question you kind of want to ask yourself, and I think it's always good to start off with this kind of 10,000-ish sort of foot view on terms of what's going on. And you can ask yourself, well, why has it been so active, right? Why are we looking at such an unbelievably active tropical system season this year, especially in the Atlantic Basin? And what's been kind of unique about this season is that the accumulated cyclone energy, or the ACE index, has not been all that uniquely strong this year, meaning that we've had some strong hurricanes, but we haven't had that many really truly intense and long-lived hurricanes. To give a scale on this, last year we had Hurricane Dorian impacting the Bahamas. It was a very long-lived, relatively large, and very intense system for an extended period of time. The accumulated cyclone energy of that system on its own outweighed the first 16 or 18 storms amalgamated from this entire season. So one strong storm can sway that index. It's why I don't always like to use it as a benchmark for what a season looks like. But likewise, you have to be a little bit careful when you think about the total number of storms, what that means for a season. But all that said, what we're looking at here, these are sea surface temperature anomalies based off of the CFSR, which is one of our reanalysis data sets, climatology from 81 to 2010. Obviously, with temperature anomalies, you have to be a little bit careful because everything is more or less outside of a few subregions in the world is more or less kind of an upward tick within this. But regardless within this, we've had an active tropical cyclone season, which more or less is trying to churn up parts of the ocean and cool off parts of the ocean to a degree, or take some of that energy and heat out of the ocean and the tropics and transport it north. We've had a lot of cyclone activity, and we still have anomalously warm temperatures almost throughout the entire tropical Atlantic region. Gulf of Mexico is still running a little bit warm. In this case, these are temperature anomalies in degrees Celsius. So the Gulf of Mexico, depending on where you go, is running anywhere between 0.5 and 1 degree Celsius above average. Up the East Coast right now, looking at anywhere in the order of 2 to 3 degrees Celsius above average in some areas. And even in our predominant cyclone formation region off the west coast of Africa here, also looking at neutral to slightly above average temperatures overall within that. So all that to say, it's warm in the waters, and warm waters never a good sign for tropical cyclones. You're basically cutting the fuse a little bit shorter on your powder keg of a tropical cyclone setup. So it just makes the impetus or the ease of that explosive convection a little bit easier to pull off. I mentioned earlier that this year we're kind of running out of names, and I thought it would be appropriate within this, and this might have been brought up last week. Unfortunately, I wasn't able to make it, but there's been a lot of comparisons and a lot of conversations ongoing right now discussing comparisons to the 2005 hurricane season, which is currently still our benchmark for the total number of systems that actually got named in that case. In this particular season, we actually ran out of storms in the alphabet. So I think it's on the order of 23 storms for we don't use quite all 26 letters of the alphabet for all of our storm names, but we used up all the letters of the alphabet, and we had to switch over into the Greek system, including our last system of the year, which actually was 2 or 3 letters into the Greek naming system, and ended up making an impact in this case in Portugal at basically the new year. Their last forecast was early January for the Hurricane Center, a really long season for them. What's interesting and different between these two seasons is that this season we have been relatively active for a relatively long stretch of time. Obviously right now is a more unique scenario compared to others. We have had a couple of major hurricanes, of course, with Laura having the impact in the Gulf Coast region, but we haven't had quite the cluster attack of a sort that you can think of with what happened towards the tail end of the 2005 season. So 2005 got off to a reasonably quick start, but by the time we got to the tail end of August, that's when Katrina was happening. So we're still in our K systems, and we've been running 3 to 5 systems usually ahead of pace from what we had in 2005. What made 2005 so unbelievable was that we basically turned the page in late August into September and October and had just a slew of really, really strong Western Atlantic hurricanes and tropical cyclones. We had Wilma, which worked its way up, clipped the Yucatan Peninsula here and worked its way across Florida. That set the record for the all-time lowest pressure recorded in the Atlantic Basin, which still holds true. They had I think it was a 2 or 8 mile wide eye in the storm. Really, really impactful system. Rita, of course, made landfall on the Texas-Louisiana coastline border. Katrina, of course, the most famous of all the systems from that year, and had a handful of others. And a lot of the tail end of that season was really impactful, not just from the sheer number of storms that we got in the second half of that season, but also with regards to the intensity of those storms. And of course, as we work our way into the tail end of the season, numbers are still very, very much up, but the question is whether or not we're going to have that surge of particularly strong storms. Sea surface temperatures certainly support the potential for that, but the other considerations that we have to take into account are some of the larger forcing mechanisms that really drive tropical cyclogenesis and drive the kind of the occurrence of tropical cyclones across the world, really, but with a specific focus on impacts over the North Atlantic. So a couple things that we can look at when we think about kind of the ingredients for tropical cyclones. One is good sea surface temperatures. 2, you need something to seed it, so some sort of thunderstorm cluster. And 3, you need some sort of favorable shear environment. In those last 2, those thunderstorm clusters, as well as the shear environment, we can actually look much more broadly beyond the Atlantic Basin for setups, in particular for the larger scale circulation of the atmosphere that favor or don't favor these scenarios. So the first thing, and many of you have probably already seen a lot of this kind of going on across the board, is what's going on with our El Nino and La Nina, or in this case, the Enso Index, or Nino 3.4. More or less what we're looking at is a scenario where we've been slowly but surely cascading here. In this case, we're looking at the Nino 3.4 index, which is kind of, at least for me, is the common benchmark I run toward for just a broad scale sense of what's going on. We've been going from a index that was kind of favoring a weak El Nino-like state, perhaps not a full-scale El Nino, but an El Nino-like state. And over the past few months here, we've really been cascading towards a flip in this index towards colder temperatures. In other words, favoring something much more La Nina-like in nature. And a big reason why this matters is that when we kind of think about the impacts of El Nino versus La Nina, your typical El Nino event basically shifts their core area of convection in the Pacific Basin further east. And in doing so, what that does is it increases the horizontal it increases the upper level horizontal winds, in this case from the outflow from those thunderstorms over the eastern Pacific. It shifts that region of strong winds aloft into the Atlantic Basin, which results in vertical wind shear, which is not a friend of hurricanes. And of course, it also, if you pile a bunch of air up at the top of the atmosphere, it's going to spread outward and it has to sink down somewhere. And generally speaking, it has a tendency to sink over the North Atlantic as one of those descending branches. That stabilizes the atmosphere, which makes it harder for those thunderstorms to form. So basically, even if you have plenty warm sea surface temperatures in the Atlantic during this stretch, if you have a whole bunch of wind shear and you have a whole bunch of subsidence and drying and warming in particular, you're just not going to have much luck forming tropical cyclones. La Nina type scenarios. So again, like we were kind of going from this situation at the start of the year towards a teleconnection to sea that's going to favor something more like this. La Nina shifts that convection further west in the Pacific, more towards the Western Pacific and a lot of the island chains in the Western Pacific. That in turn pulls that area of sinking air and pulls that area of strong vertical wind shear away from the Atlantic. And as such, suddenly we have a less stable environment, less stable atmosphere, as well as a less shear-driven atmosphere. So when that happens, you're much more favorable to form those thunderstorm clusters, as well as to form storms that can survive in a reasonable wind shear environment, because you're not going to decouple the core of your latent heat release with those thunderstorms from the core of the storm itself. Just makes it more and more reasonable for those storms to survive. So when you also couple that with warm sea surface temperatures, you suddenly check off 3 of those boxes that you're looking for robust conditions for tropical cyclone formation. So that's on the big picture, like the real like long-term seasonal side of things. We can also jump more towards the shorter time scale side of things. And this has to do with what is called the MJO, or the Madden-Julian oscillation. So the Madden-Julian oscillation, for those of you not familiar with it, it's basically this amalgamated area of rising motion that propagates around as a big wave around the equator. It has strengthening and weakening cycles, just like we see with our typical mid-latitude systems, with pulses of convection and pulses of sinking motion for this particular case, just like we see with our large-scale patterns in the atmosphere. Different wave propagation characteristics and all that. If you take a 422, I think is where a lot of that gets covered. There's a lot of really good details on that front. But we can basically take the anomalies and outgoing long wave radiation, which tell us basically where we have thunderstorms or where we don't, or enhanced thunderstorm activities. We can take that and basically get a sense as to where this complex of rising motion is in the atmosphere. And the reason why it matters is that if you have a large area of rising motion, just like we saw with El Nino, there has to be compensating sinking somewhere else. So we pay attention to where the MJO is active, because that tells us areas where it's active. So in this case, we can kind of classify it by different regions, and this time the maritime continent, the Western Pacific, the Western Hemisphere, and the portions of Africa, as well as the Indian Ocean. We can track where that core of thunderstorms are, which tells us that we have thunderstorms, which can be a seeder for tropical cyclone activity. But it also tells us correspondingly that areas away from that are going to be a little bit more favorable for sinking, less favorable for tropical cyclone activity in that particular case. In our current situation, we basically have the MJO. So this is a phase-based diagram. So basically, we take into account a couple of different attributes with regards to what's going on with the Madden-Julian oscillation. We can plot it on this diagram, and basically it kind of acts as a tracking mechanism. It tells us more or less how strong it is. So as you go radially away from the center here, how strong the MJO is. And then as you work your way circularly through these different regions, it tells you approximately where that convection is happening. The dates here are the dates corresponding to the calendar. So in this particular case, we're looking at early August. So in early August, we were in phase 4 and kind of moderately strong. Worked our way across here to mid-August, working our way into the Western Hemisphere and the African regions. By tail end of August, we were working into kind of the more or less kind of Central Africa. And then as we worked our way into September, we've kind of worked our way into the Indian Ocean and maritime continent region, but we've more or less started to weaken within that. So just like El Nino, there's rising motion with these thunderstorms that results in divergence at the top of the troposphere, so outward motion, and somewhere we have to have compensating sinking. And as we understand more and more about the MJO, we're starting to realize that there are certain components of it that favor or don't favor robust tropical cyclogenesis. So in this case, this is a paper from back in 2000, so some of the terminology that we were seeing at that phase 1 through 8 aren't necessarily applied here. But what we do see is that for our MJO type scenarios, there's certain MJO phases that are more and more favorable for tropical cyclone formation. And in this particular case, they're looking at portions where we see a lot of activity with Sally today with regards to what's going on in the Gulf of Mexico region. And in particular, we can look at our 850 millibar wind anomalies. So in this case, these are anomalies for what they call their westerly phase and their easterly phase of those anomalies. So we kind of see here in figure 2, westerly phase, more tropical cyclones, easterly phase, less tropical cyclones. If we want to look at 850 millibar maps, we would expect to see essentially a cyclonic kind of circulation here with maybe strong westerly anomalies off of the southern coast of Central America, easterly phase, kind of an anticyclonic anomaly and enhancements there, which you can kind of think about if you extrapolate down. This should suggest some sort of broad area of low pressure here or some broad area of high pressure here. We can go back to the CPC website, and if we scroll up here, we can look in this case at our 850 millibar wind anomalies for the period of time that we were looking at about a week ago, and then in the past handful of days. And broadly speaking, we're not really seeing too strong overall of a signal. Maybe if you squint your eyes, you can make an argument that we have an easterly signal here from the September 2nd to September 6th period. Again, maybe if you squint your eyes, you can argue that we have a cyclonic signal here. But in my books, not really seeing too strong overall of an MJO signal within that small subscale region. But certainly some of these long-term trends have favored a little bit of favorability for tropical cyclones. All this to say, there's a lot of money and pride in trying to get seasonal forecasts of hurricanes right or wrong. But I can tell you from watching this over time that frequently there's also a whole lot of egg that ends up on faces trying to forecast these systems going forward within time, because it is a very challenging process. As you probably put together, there's a ton of variables at hand and a ton of considerations at hand overall within this. Always helpful as we talk about really impactful seasons. Again, you know, when you kind of look at this, you're thinking to yourself, all right, well, I mean, we talked about this idea that at the start that this is abnormal, but how abnormal or not is it? And cyclone climatologies can be really helpful from that standpoint. So in this particular case, what we want to look at here is a couple of regions. Sorry, I just want to make sure I have my figures in the right order here. These are the cyclone points of origin and the cyclone tracks for this time of year from the climatology, in this case 1851 to 2015 from the National Hurricane Center. 216 total cases between the eastern Pacific here as well as the tropical Atlantic. We can see that the formation of a system, kind of like what we saw with Sally, is not that unusual. We see quite a few systems that form in the vicinity of the Florida Peninsula here, quite a few that form in the Gulf Coast region. But certainly at this time of year, we also keep a very close eye on these easterly waves that come off of the Atlantic and kind of work their way along. A lot of very kind of wonky tracks. You might see a lot of kind of spins and twists and all sorts of stuff going on in the Atlantic. And we'll actually see how for Paulette, that's actually a track that we're potentially looking at for that, as well as the potential for Sally as we work our way forward. Taking this information, we can then ask ourselves, how frequent is it that we see tropical cyclones impact these regions? And we can talk about this in terms of the return period. So the return period is just a statistical argument as in terms of how frequently or not we see these systems impacting a region. So in this case, a value of 7, for example, like we see in South Florida, or as well in the kind of the southern flank of Louisiana there, tells us that on average, we would expect to see a hurricane impact that region about once every 7 years or so. It doesn't mean that if you have one hurricane one year, you're gonna have to wait another 7 years for a new one. You can have multiple hurricanes clustered on top of each other. A perfect example of it is this year, right? So we see a return frequency here, return period on the order of 10 to 15 years, give or take, for the Louisiana coastline. And they're potentially looking at the possibility of 2 hurricane landfalls within 3 weeks of each other in that same exact region. So it's always important when talking about return periods to realize that these are statistical metrics that don't tell us anything per se about a forecast for a given season, just a sense of how often we should expect these events to happen. But what we do see is that the areas that we're kind of looking at, they're kind of used to getting hurricanes, right? They get them once every decade or so on average. Major hurricanes a little bit less frequently, but still once every 2 or so decades on average. So these kind of high impact events aren't entirely unusual. They're pretty used to dealing with these. And this is good because they have in theory, they should have developed a stronger and more robust system for handling these hurricanes, from evacuations to mitigation efforts such as putting up storm walls and so on, pumps in New Orleans, things along those lines. The reality is that memory is shorter than the return frequency for hurricanes usually. So as such, those mitigation efforts don't always work as quite as well as we want, but they are used to seeing these events on a pretty routine basis. The downside is that they also, more often than not, if you take this frequency, it tells you that pretty much every generation that grows up in southern Louisiana, coastal Alabama, or coastal Mississippi is more or less used to seeing one major hurricane every generation in their lifetime, which means that there's a lot of running memory of these storms and how they had an impact. This can benefit you if you have very strong hurricanes and they're very detrimental, but they can also be adverse if a strong hurricane impacts a region and you don't personally get impacted that much. People get comfortable with storms, which gets really dangerous when you have weaker storms that can have really significant overall impacts. Another way you can look at this is you can break this down to a smaller scale. This is the return frequency, or the total number in this case, not the return frequency, but the total number of hurricanes over a 110-year period that impacted various regions along here by parishes, counties, or boroughs along the coastline here. So we can see, for example, Cameron Parish, where Laura made landfall, in this case has had 14 between the 1900 and 2010 period. If we go a little bit further east, we can see still quite a few in this kind of region. And then when you get up into the nook of Florida, which is relatively hard to hit, you see fewer overall events within that. So now that we've left ourselves in a situation where we kind of have a sense of what the norm is, let's take a look at some of our overall events that are ongoing right now at these last kind of bits of time here. So this is Paulette. This is making landfall in this case, this little white dot kind of right here. That's Bermuda right there. So in fact, they were subject to a landfall and a direct hit from the eye of the storm overnight. I always like to look at the Ram slider from Colorado State. I find that they have a great overall way to analyze a lot of the GOES data overall within this. It does take a little bit of time sometimes for stuff to load in, but I really like to use it to oftentimes look at the visible satellite as well as what's going on with our lightning trackers to get a sense of where we have lightning. So some tropical cyclones have a lot of lightning in them, some don't. Really kind of varies from system to system. There's growing research, and this is kind of the beauty of having a lightning tracker in our GOES satellites now, is that we can actually start to more robustly understand the role of lightning in terms of tropical cyclone strengthening, weakening, and predictability. So something certainly that we're trying to figure out on that front. But Paulette is looking a lot less healthy this morning. You know, the impact on Bermuda wouldn't have had much of any impact on the actual structure of the storm, but certainly overall it's looking a little bit less healthy this morning with regards to the eye kind of breaking down towards the tail end here overall within that. Jumping forward to where we're kind of looking at things, this is from Brian Tang's website. So Brian Tang is a faculty member up at the University of Albany. He has a really nice breakdown of the guidance for various tropical cyclones. And more or less what we can see here, what we're looking at is the probability of Paulette kind of following this particular track, or basically how tightly or how dispersively the ensemble members are clustered for the various predictive models of where the storm should go. So in this case, I'm pulling up the GEFS, which is the US-centric modeling system. And in this case, we can see very, very strong agreement in terms of what's going to happen with Paulette. And the big reason for this is that cold front that came through yesterday is actually going to be picking up the storm for a period of time and kind of pulling it into the mid-latitude flow for a period of time. It is, however, going to get deposited over the North Atlantic, and certainly the remnants of the system could, in theory, act as a seeding for a future storm overall within time. When we talk about those kind of weird, wonky tracks, certainly possibilities there for that. This is what the European model is showing for the same clustering of the ensembles. And again, we see a very strong agreement on that front of the storm being picked up, brought out into the really into the core of the North Atlantic to 45 to 50 degrees north before it kind of gets deposited and starts to break down overall within time within that. What does that mean for an intensity standpoint? Well, the storm itself is under probably at its peak intensity phase overall within this, and then it's going to start to weaken overall within time. Now, some storms do intensify as they become extratropical, but it really depends on where the hurricane itself is relative to the upstream Rossby wave that's picking it up, or the wave that's actually driving it in the atmosphere. So let's turn our eyes to the more prevalent situation at hand. I thought that the satellite presentation on Sally this morning was a little concerning. It's a little bit hard to see, but you might notice how there's this kind of outward swinging ring within time that's kind of blasting away at the top of the storm top. And in the middle, we see this huge clustering of lightning. And that tells me that we have a very robust convective core ongoing within the system. You can actually see the gravity waves rippling along. It's like dropping a stone in water, except we're looking at it from underneath the water as opposed to the other way around. But what we're seeing is a really, really big convective burst this morning in Sally. And that's been kind of the big fear with this system, is that we have a very slow moving system. We have very warm sea surface temperatures. We have very little shear overall within that. So everyone's been kind of waiting on pins and needles and edge, waiting for whether or not there was going to be this big convective burst, and if that was going to kind of kick off the start of a rapid intensification process of the system. I am watching this very nervously because I do think that this is the sign that we've been waiting for. So we will keep an eye on what's going on overall within the system itself. To get into a bit more detail, we can see that these spiral rain bands are starting to work their way a little bit onshore here. This is from the MRMS composite reflectivity right now, which is a great tool overall if you're trying to do some radar analysis across the entire United States. We can see the system is starting to get itself a little bit more organized. Perhaps also it's getting closer to the radar network, so it's a little bit more well captured by our radars. But certainly the areas in in western Florida here are starting to feel the impacts of those spiral rain bands working onshore. In terms of the system itself, right now we do have aircraft actively in the storm. We'll hit a quick refresh here. And pop down to our surface analysis. So in this case, we do have quite a bit of aircraft data trying to pull up measurements. Winds haven't quite responded at the surface. We do see flight level winds peaking out at about 65 knots, which should put our surface intensity somewhere around 50 or so knots. Our SFMR winds are kind of coming in around the same area. So we're probably looking at a 50 knot overall tropical cyclone within this. What's been very fascinating is the radius of winds. So in this case, these are flight level winds being shown here. And what we see is that in the western side of the storm thus far, really not a lot of strong winds overall. On the northeast flank, much stronger overall winds. Those are flight level winds in the 50 to 60 knot range. To the southeast here, we see winds in the 50 to 60 knot range. A lot of that, to a certain degree, has to do that we did have a ridge off to the northeast of the system, which was helping to propagate it along to the west and prevent it from surging too far north. But certainly as time goes on, as the system begins to continues to intensify, you certainly will look for that wind field to become a little bit more coagulated around a central point around the center of the storm, as opposed to being offset like this to really showcase robust strengthening overall within that. So certainly something to keep an eye on as the system goes on. What has been jumping out to me is that we currently have a tropical storm. The potential for it to strengthen is there. Rapid intensification is probably the hardest thing to forecast for tropical meteorologists to date. But what we are looking at is an exceedingly slow moving system that's going to drop a lot of rain. This is the NHC Hurricane Tracks right now overall within this. You'll notice a very slow propagation. We're looking at 1 a.m. Tuesday, 1 a.m. Wednesday, 1 a.m. Thursday. That's a lot of time for one small region to be stuck underneath the thunderstorms and the precipitation that's ongoing within a tropical cyclone. Certainly a bit of a risk for a storm surge, especially this region is very prone. River deltas are always very, very scary places from a storm surge standpoint. But at this point in time, when we're looking at the track itself, precipitation to me starts to become a very, very big concern. In this case, the National Hurricane Center actually brought out a 20 plus inch, sorry, this is the WPC outlook, 20 plus inch potential for precipitation, and that does not happen too often. We're going to circle back to that in a minute, but this is the current outlook. This is the GEFS probabilistic outlook from the 0Z models for where we expect the system to go. And we can see a general agreement in terms of very slow and steady propagation, making landfall very close to New Orleans, probably potentially passing over it, certainly having an impact on a very robust impact on the Louisiana deltas here, as well as portions of Mississippi and Alabama, and slowly but surely working its way out to our south, not too similar to what we saw with Laura. EPS is showing pretty similar outlooks, maybe a little bit further depressed to the south in this particular case, and a slightly slower overall propagation as the system works its way along. And that detail is going to play a huge factor in terms of how strong overall our system is. If we look at the convective allowing models, these are our hurricane models. This is the HWRF run from this morning for Sally. This is composite reflectivity. We can see, again, a very slow moving system starting to intensify. So in this case, the HWRF has it making landfall around 965 millibars. We can see that it initializes around 993 millibars. So it's 30 plus millibars of deepening over the next 12 to 24 hours. So certainly concerning overall within that. Making landfall and then more or less parking itself overall with time before slowly working its way maybe right back out into the Gulf as time goes along. For those of you who are thinking, this looks familiar, well, that same kind of curly Q loop of a storm just stalling on the coastline happened with Harvey. Harvey was a much stronger hurricane, of course, at landfall, but the impact from the precipitation was devastating. Portions in the Houston area got upwards of 60 inches of rain. And the WPC has only issued a day 3 or a 3-day outlook of high risk of flash flooding and high risk of severe extreme rainfall. They've only done that a few times now. I forget the third tropical storm that they did this with, but Laura is number 2, and Harvey was, sorry, Sally right now is third instance of this. The first time they ever rolled out that high confidence of a forecast was for Hurricane Harvey. So for me, when I think about the potential for this storm, by and far, I think the biggest risk of impact right now lies within this potential for really extreme precipitation over this region. That said, there are still other impacts that are going to be ongoing. Within that, we can certainly see the risk for storm surge. This is a bad angle for a storm to hit the Mississippi River Bayou Delta in this particular case. So certainly a lot of risk and a very strong overall potential surge given the punch that's come in with the potential for winds overall within this. So a lot of concern in the New Orleans area, not just because of the potential for storm surge, but also because 20 inches of rain is really hard for any system to keep up with. Quickly within this, kind of popping over to the current research front, this is actually a scenario here where we're looking at the 20th percentile of storm forward motion speed. So it's kind of giving you a sense here of what's the low end kind of wind speeds that you see. So if you think about a distribution of 100% of tropical cyclones, this is looking at the bottom 20% in this case for storms that are actually propagating along. And in this case, it's only, when we get down to this kind of propagation speed, the Hurricane Center is probably at 5 to 6 knots of forward propagation speed. In this case, we're really looking at really a low frequency event. So we don't see these kind of slow moving events too often in this region is kind of what I'm trying to take home within this. So the reason why I'm worried is that these regions are used to tropical cyclones. We see them very frequently, especially when you amalgamate in tropical storms plus hurricanes, you have a pretty high return rate on these things. They have a recent memory of a lot of really high impact events Laura, Katrina, Rita, Michael, things along those lines. And those who were in the direct impact of those can think to themselves, you know, this is a really awful instance. I don't want to live through that again. But then you also look at a storm like Sally and you go, oh, it's just a tropical storm. I don't really need to worry as much about this event. That mindset becomes very dangerous and oftentimes very deadly when you have a storm that is doing something unusual relative to what you're used to. A slow-moving tropical storm with extreme flooding is very different than a fast-moving tropical storm where you get 4 to 6 inches of rain. So a lot of concern on that front. As long as it's good for time, I'm going to take 2 last minutes to show one last event that I thought was interesting. Again, all tied to these kind of mid-latitude systems. And that is what I think, I didn't analyze it in too much detail, but I think we had evidence of what's called a predecessor rain event over the Tennessee Valley area. So for those of you who are watching at home, we had, oh no, did I lose my image here? There we go. These were the precipitation values yesterday for Tennessee. And in terms of the cold front winners, they were the big winners. They had upwards of 6 to 8 inches of rain overall in association with that same cold front that we were impacted by here in central PA. Now, oftentimes when you have a tropical storm in the vicinity of a frontal type feature, doesn't have to be in direct vicinity, right? We can see a big difference in terms of where these two systems are. Oops, sorry, the zoom here is very, very finicky. But overall within this, what I'm trying to say is that in the vicinity of this cold front that we had over the eastern United States in the Appalachian Valley or Appalachian Mountains, we had a really nice enhancement of precipitation right about in this region. And what we call predecessor rain events are essentially events where you have a tropical cyclone somewhere in the vicinity. So in this case, kind of in this neck of the woods, you have a trough in the upper levels. You have, usually this occurs in the equatorward entrance region of the trough. So even though in this particular case, we can't quite see that analyzed with the way that they're doing their contours, you can make the argument that we have a bit of a jet streak elongating here from, say, central Illinois upwards into our northeast quadrant overall within this. So if you were to draw out a jet streak within this, you could see that the Tennessee area is kind of in that equatorward entrance region of the jet. When you have that oftentimes coupled with a frontal feature and you have the broader circulation in association with a tropical cyclone, we can get what's called a predecessor rain event. It can occur easily hundreds to upwards of 1,000 kilometers away from the actual hurricane circulation itself. It has to do with the advections of moisture and other kind of features that are ongoing within that. But what you can do is take a common cold front that doesn't seem all that discerning, and you can really hijack it and make it a much, much stronger overall cold front. In this case, instead of having precipitation values of 1 to 3 inches, you end up with precipitation values of 6 to 8 inches. These events have been known to be deadly events for many tropical cyclones along the East Coast. It can happen in association with cold fronts. It can happen in association with mountains and things along those lines. But they're kind of one of those surprise events that can oftentimes pop up separate of what we actually see with these large-scale tropical cyclones. So definitely, certainly an impactful event from that standpoint, and something certainly to keep on looking into in more and more detail. Last but not least, I thought I'd just throw in State College because, you know, it is a local weather discussion. This is the new National Blended Models 1D viewer. These are the statistical outputs from the National Blended Models for the UNV area. And all I can really leave you as a take-home effect here is it's looking like a pretty nice week. Potential for a little bit of precipitation as the remnants of Sally work our way to the south. Not quite sure what's going to happen within that because we do have a cold front. So whether the storm ends up further north or further south will have big impacts in terms of what our total precipitation is. Right now, the national blend average is putting us around 3/4 of an inch. I'll believe it when I see it. But overall within this, what we're looking at is really a nice week ahead. A cold front coming through in the latter half of the week, dropping down temperatures. We're looking at yet another stunning weekend weather-wise here in the State College area. It's a little bit painful right now, but it's really nice when you want to get out. But temperatures in the 60s, 70s, low temperatures sitting in the 40s to 50s. Doesn't get much better than that for the summertime overall within that. So I'm going to wrap up there. Sorry for chatting so much. I see some Q&As. My apologies for not noticing the chat earlier. But John, yeah, latest from Bermuda, pretty gnarly there. It has been blasting away on them with what's going on within that. So hopefully they've been doing all right overall within that. But yeah, outside of that, some more chat kind of popping within this. Yeah, NHC just declared TD 21 is now Vicky as well. So yeah, a lot going on within that across the board for the tropics just becoming more and more busy. So I'm happy to answer any questions or otherwise. Thanks all for your attention and your time. Really appreciate it and appreciate the opportunity to be able to present.
Thank you, Dr. Bowley. And I really liked how you kind of tied in more of a social science aspect with just the amount of precip and people perceiving it not as dangerous. I'm really interested in that. So that was cool to hear. If you have any questions, again, please put them in the Q&A. Otherwise, I'll leave that up for a couple more seconds, and then otherwise we can just end the meeting.
Good. Thanks, Marissa. Pleasure is all mine. Yeah, George, that's a great question. What does 20 inches of rain do on something as flat as the Delta? That's a fantastic question. There's not a lot of drainage points. So you're going to run into a very unique situation that really concerns me, that we've dumped a lot of rain yesterday into the Tennessee Valley region, which the timing on it's going to be just as the storm is making landfall in New Orleans, or just after that floodwater will be working its way down the Mississippi Delta. And then you tack onto it a bunch of rain in the Delta itself, as well as the potential for storm surge and otherwise. And there's not a lot of space for that water to go other than the lowest point around, which, you know, for New Orleans, that is kind of the low point around. And you got to hope that you have pumps that are working properly to keep up with it. And my understanding of the pumps in New Orleans is that they do not have the capacity to keep up with this much rainfall, let alone the risk for storm surge. Surge is low enough that the levees should hold. Again, there's a lot to unpack in that statement, but I don't know if New Orleans water pumping system actually has the capacity to keep up with this level of rainfall rate. So I suspect we're going to see quite a bit of freshwater flooding actually from this event, more than saltwater flooding in that metro region. And I think you're going to see a lot of potential for Mississippi River flooding as this thing slowly but surely ramps itself up. So.
Perfect. Okay, so if there aren't any more questions, I'll just go ahead and end the meeting. Once again, thank you, Dr. Bowley, for volunteering to do our briefing this week.
Yeah, my pleasure. And thanks everyone for attending. Thanks to Chris and Alex for organizing, and look forward to dropping in on these in the future.